Okay. So in mathematical physics, we have a very important concept that we use uh, in different topics and in different chapters, and that is known as Dirac delta function. Dirac delta function. Okay. So Dirac delta function, how the definition comes, and this will be important for uh, many chapters in mathematical physics as well as uh, in quantum mechanics also. Dirac delta function is very important. Huh? But how the concept comes, let us see. Suppose I have a function which is like this. This is function fx, and it starts from, it is between a and b, between some x1 and x2, let me write. And this is a and this is b. Okay. So suppose this is some function. So this is kind of barrier function. It will be between this, it will exist between this, and outside this it is 0. Okay. The height is b and the width is small a. And suppose this function is defined like a and b is always 1. That means the area is always 1. Okay. So this is, ये बहुत नॉर्मल है, ये चीज़ तो बिल्कुल नॉर्मल है कि मैं एक फंक्शन डिफाइन करना चाह रहा हूँ जो कि किसी लिमिट x1 से x2 में it is having height b and otherwise it is 0. Okay. So when you define it, you can say that suppose, what is the coordinate of this? Suppose this is some, let us not make it complicated. Some coordinate you define, this is suppose x1, this is x2. So between x1 and x2, it is b and otherwise it is 0. So this is a simple function. Okay. Now this thing I want to remain conserve. इसको मैं बदलना नहीं चाहता. I want this to remain same. But what I want is that I will squeeze the value of a and the height will become b. So I will make a very, very small. So b will become very, very large. Now let me explain you mathematically what is very small. So I can say that a is suppose 10 to the power minus 5. This is a very, very small quantity. And then b will become 10 to the power 5. So if you multiply a and b, still you get 1. Right? If you write here also a and b, this is equal to 1. So mathematically, the quantity which is very, very small is 0, and the quantity which is very, very large becomes infinity, and still the area is conserved. Still the area is 1. Correct? Now, this is called Dirac delta function. This is called Dirac delta function. This is called Dirac delta function, and how we define it, this width was a, and suppose the location is some x naught. The location of this delta function is x naught. So we define this as fx is equal to, this is very small. We define it like x minus x naught. This is the representation. This is the representation of the delta function. The reference book for Dirac delta function is M-BIOS. Okay, this is the reference book for this Dirac delta function. Now, इसका मतलब क्या है? The meaning of this is, what is the height of the function? Height is infinite, very large. What is the width? It is almost zero. So that means it is only located at the point x naught, and otherwise it is absent. So this delta function is present at x naught and absent elsewhere. Delta function is present at x naught and it is absent elsewhere. ठीक है? Now यहाँ पे area is 1. Here also area is 1. And how we calculate the area under the curve? How we write area under the curve? We write integral fx dx. You know this now? If there is a function, how we write area under the curve? Integral fx dx. So in this case, it will be integral delta x minus x naught dx if the limit is starting from the left of x naught and goes to the right of x naught, then this should be equal to 1. Where epsilon is some positive small number. Or in general, what we can write? In general, what we can write is integral minus infinity to plus infinity delta x minus x naught dx is equal to 1. तो मैंने लिमिट अगर माइनस इन्फिनिटी से प्लस इन्फिनिटी कर दूं, if I put the limit from minus infinity to plus infinity, then it will be always equal to 1. So ये ध्यान रखना कि the height is not 1. Height of the delta function is very large. Height of the delta function is very large. Just the area under the curve is 1. ठीक है? So this is the first important property of the delta function. So ये सारा note करते जाना. This is the first property which is very important of the delta function. And the second property is like this. If I write integral minus infinity to plus infinity fx delta function x minus x naught dx. So because delta function is always having the value equal to 0 except at x is equal to x naught. सो हर जगह इस इंटीग्रल की वैल्यू 0 मिलेगी एक्सेप्ट एट x नॉट, और जैसे ही x नॉट पे आओगे you will get f x naught and that area will become 1. So answer will be f x naught. Answer will be f x naught. This is the second important property of the delta function. Okay, this is second important property of the delta function. तो यहां तक क्लियर है? These are the two important properties of the delta function which are very very basic, और इसको हम लोग को we have to use it. Okay, now comes the derivative. अच्छा, एक बार रिप्रेजेंटेशन और बता देता हूं कि डेल्टा फंक्शन इज ऑल्सो represented like this. If I write here delta x minus x naught, so I can just represent it like this. This is also delta function. Or without cap also you can write only this much. I can write delta x minus x naught here. This is x-axis. This is also delta function. If I write minus of delta x minus x naught, suppose I want to plot, so it will be like this. Area will be -1. And if I write delta, this is x-axis, this is y-axis. If I write delta x plus x naught, then this is the location of the delta function. तो ये सारे रिप्रेजेंटेशन हो गए. नाउ कमिंग टू, ठीक है भाई, समझ आ रहा है सबको ना? नाउ कमिंग टू द डेरिवेटिव्स. Derivatives of.
Sir, can you please go back to the previous page once?
Yes. Which one you want to ask?
This one, sir. Means I didn't ask. I didn't draw that. I just want to draw that.
Sure. This
Yes,
is.
sir. I am done. Thank you.
This is.
Yeah, that one.
Minus
No.
x naught. ठीक है. Now, we can discuss more properties of the delta function. Okay, and please remember, if there is a quantity, listen this carefully what I'm saying. If there is a quantity which is present at one place and absent at all other places, you can represent it by delta function. So if a quantity is present at one, I mean, it is not necessary that it is position. It may be in time also, or it may be some any other quantity in any space. If I am writing at one place, so that place is not necessarily the position. It may be time, it may be momentum, it may be any space. ये बात सब लोग ध्यान रखना. Okay. So if a quantity is present at one point and absent at all other points, it can be represented by delta function, by Dirac delta function. ठीक है ना, ये बात क्लियर है. Example, a point charge is present at one point, absent at all other point. Suppose you open a bottle of perfume. So at t is equal to 0, the molecules are present at one point. The molecules of the scent, they are present at one point, they are absent at all other points. So these all things can be represented by delta function. So even in quantum mechanics, if something is there which is present at one point initially confined, so you can represent it by delta function. Okay. Now let us discuss some properties of Dirac delta function, and first is derivative of delta function. Derivative of delta function. So integral minus infinity to plus infinity phi x delta function x minus x naught n dx. What is this? N means? Anybody? What is this n means?
Dimension.
Nth derivative of delta function. Nth derivative of delta function. This is equal to minus 1 to the power n and f n x naught. What is this n means? Nth derivative of delta function. You can see it for first derivative. I can just prove it. एक बार देखो जरा, अगर मैं ऐसे ले लेता हूं माइनस इन्फिनिटी टू प्लस इन्फिनिटी फाई ऑफ एक्स डेल्टा डैश, आई मीन फर्स्ट डेरिवेटिव x माइनस एक्स नॉट डी एक्स. ठीक है, तो हाउ आई विल डू इट? फर्स्ट फंक्शन integration of second and this integration will be 1 and minus derivative of first function and integral of second. 1 सेकेंड, जैसे करते हो ना नॉर्मली इंटीग्रेशन वैसे करो. हाउ वी डू द इंटीग्रल्स? If two functions are there, we do it like this, na? First function integration of second, which is delta, which is 1, and you will put limit to this, na? Minus integral of differential of first function, integral of second, and dx. It is like this. यहाँ पे डेल्टा x minus x naught. Okay. Now put the limit. If you put upper limit, then the delta function will become 0. If you put lower limit, then also delta function will become 0. So this will become 0 minus, this will become phi dash, property use कर ले रहा हूँ, x naught. So this has become minus phi dash x naught. देखो फॉलो कर रहा है ना nth डेरिवेटिव वाला कॉन्सेप्ट, n is equal to 1 ले लो तो सेम आ रहा है. So this is how it works. ठीक है. देखो ध्यान से, किसी को डाउट तो नहीं है? टेल मी, बताओ भाई, सबको क्लियर है? नेक्स्ट पेज पे जाऊं? ओके. Now this is the property related to derivative. So I hope everybody understood. Suppose you have integration minus infinity to plus infinity sine x delta x dx. So what will be the answer? Minus 1 to the power 1 sine dash 0, which is equal to minus 1. Is it clear? Now there is also a function called unit step function. Unit step function. यूनिट स्टेप फंक्शन यूनिट स्टेप फंक्शन क्या है? कि अगर मैं लिखता हूं u ऑफ x माइनस ए, तो ये फंक्शन a से शुरू होगा और उसके बाद हमेशा 1 रहेगा. दिस इज कॉल्ड यूनिट स्टेप फंक्शन. इट विल स्टार्ट फ्रॉम ए, or even if I write, suppose a is positive here, a is positive. If I write u x plus a, it will start from minus a and then it will become 1. This is called unit step function. And if I write u of a minus x, it will start from a and left hand side it will remain 1. And if I write a function which is u x minus a minus u x minus b, so it will become a barrier function between a and b, like this. बिकॉज क्या होगा कि a के बाद 1 होगा और b के बाद 1 होगा, तो व्हेन यू विल सब्सट्रैक्ट दैट पार्ट विल वाइप्ड आउट. ठीक है, जैसे आफ्टर a it is 1 and ux minus b is after b it is 1. So when you subtract, this part is wiped out and a barrier remains. So barrier can be represented by ux minus a minus ux minus b. A barrier function can be represented by ux minus a minus ux minus b. Now, if you see clearly, the function is like this: u x minus a. This is the function. Now you check the slope of this function. What is the slope of this function? Here the slope of this line is 0 and the slope of this line is also 0. But the slope of this line is infinite. So that means derivative of unit step function will be a delta function. So I can represent u dash of x minus a is equal to delta function x minus a. The slope is used. अब ये देखो कितनी बढ़िया बात है कि a से पहले यूनिट स्टेप फंक्शन का डेरिवेटिव 0 है, a के बाद यूनिट स्टेप फंक्शन का डेरिवेटिव 0 है, और एग्जैक्टली एट a it is tan 90 which is infinite. So this can be used that the derivative of unit step function is delta function. Also very very important property. ठीक है ना? Derivative of unit step function is a delta function. Now there are some more properties that can be derived. For example, x of delta x, this will be 0. देखो समझ आता है? x of delta x will be always 0. Anybody can explain this? Because it is what? X.
X has the only value x is equal to 0. So at that time x will be 0. So
Right. Because it is x of delta x minus 0. So डेल्टा फंक्शन तो हमेशा ही 0 है, सिर्फ 0 पे 0 नहीं है, और 0 आते ही यहाँ x को 0 से मल्टीप्लाई करना, x इज इक्वल टू 0, तो इसलिए ये 0 हो जाएगा. ठीक है. b x into delta dash x, this is minus delta x, x into delta dash x is minus delta x, and x square delta double dash x is 2 delta x. बस ये 3 याद रख लेना. इसको डिराइव भी कर सकते हैं, we can derive it also. So these are properties. ये तो ये एक प्रीवियस ईयर क्वेश्चन भी है, ये वाली प्रॉपर्टी. डेल्टा डैश एक्स इज इक्वल टू माइनस डेल्टा एक्स अपॉन एक्स, द डेरिवेटिव ऑफ डेल्टा फंक्शन. Now there are some more properties. First one is, what is, so delta function is an even function. So delta of minus x is delta of x. Delta function is even function about origin. And delta of x minus a and delta of a minus x both are same. But the derivative is not even. So delta dash of minus x is equal to derivative of is equal to minus delta dash x. So write that derivative of delta function is odd function. And सबसे important है, most important, what is delta function of fx. अगर डेल्टा फंक्शन के अंदर कोई फंक्शन आ जाए तो ये सम बहुत सारे डेल्टा फंक्शंस आ जाते हैं यहाँ पे. तो इट इज समेशन आई डेल्टा एक्स माइनस एक्स आई अपॉन mod of f dash xi. So summation means जितने भी रूट्स आ रहे हैं, what is xi? xi is roots of fx. That means you put fx is equal to 0 and suppose you get values x1, x2, x3, then you have to write it as a sum of 3 delta functions. ये वाला बहुत इंपॉर्टेंट. इसका एग्जाम्पल लेते हैं. सपोज आई हैव डेल्टा एक्स स्क्वायर माइनस ए स्क्वायर. then how I will write it? I will just put this is equal to 0, fx is equal to 0. So I will get a and minus a, right? So it is summation. So first of all, I will take x is equal to a. So it will become delta x minus a upon f dash will become 2x, and then it will become 2a, then plus next one delta x plus a, and again it will become 2a. So ये क्या बन जाएगा? It will become 1 upon 2a delta function x minus a plus delta function x plus a. ये मॉड लगा हुआ है ना, तो जब माइनस भी होगा तो प्लस हो जाएगा. ये देखो, सबको समझ आया लास्ट वाला? ठीक है, बोलिए भाई ऑनलाइन स्टूडेंट, टेल मी, आर यू अंडरस्टैंडिंग दिस?
Yes, sir.
तो यहां पे कोई भी फंक्शन आए तो उसको हैंडल करने का तरीका ये है कि ये वाला डेल्टा फंक्शन सम बन जाएगा. जस्ट fx को हमें 0 के इक्वल पुट करके रूट्स निकाल लेने, और ऑब्वियसली डेरिवेटिव ऑफ दैट पॉइंट शुड नॉट बी 0, क्योंकि डिनोमिनेटर में 0 नहीं आ सकता. ठीक है, ओके. फाइनली अभी तक we are discussing in one dimension. So suppose I want to discuss in 2D, how I will write the delta function in 2D. So I will write it like this: delta of x minus x naught, delta of y minus y naught, delta of y minus y naught. This is delta function in 2D. So that means if I write integral minus infinity to plus infinity fxy, then we will have x minus x naught, y minus y naught, dx dy, and this is equal to f of x naught comma y naught. और ऐसे ही अगर मैं 3D में लिखूं तो आप अब नाउ गेस कर सकते हो, राइट? 3D में I will write delta function x minus x naught, delta function y minus y naught, delta function z minus z naught. And when I write integral minus infinity to plus infinity, क्या बन जाएगा? f of x comma y comma z delta x minus x naught, delta y minus y naught, delta z minus z naught, dx dy dz. क्या बन जाएगा? f of x naught, y naught and z naught. ये कार्टेशियन का 1D 2D 3D हो गया। Notation is written like this also sometimes. इससे क्या मतलब? 3D, del x minus x naught, del y minus y naught, del z minus z naught. अगर if it is 3 written here, this is the notation. This is equal to del x minus x naught, del y minus y naught, del z minus z naught. ठीक है भाई? और यही चीज यहां तक क्लैरिटी है सबको? इज इट क्लियर? And when you go for spherical polar, suppose it is written del cube r minus r naught. This is three-dimensional spherical polar. Its value will be 1 by r square sine theta del r minus r naught del theta minus theta naught and del phi minus phi naught. This is the spherical polar. And in cylindrical, del q rho comma rho minus rho naught is equal to 1 by rho del rho minus rho naught del phi minus phi naught and del z minus z naught. This is cylindrical. ठीक है? ये सब हम लोग यूज करेंगे। सपोज डेल डॉट आर कैप बाई आर स्क्वायर है, तो ये क्या बन जाएगा? इट इज 4 पाई del r. And if it is del square 1 by r, it will become minus 4 pi del r. Divergence of this will be written in the form of delta. अब ये बेसिक था. Now we have everything in our hand, we know everything. Only problems we have to do just to materialize this. So Is it clear up to this? ठीक है, तो इन नेक्स्ट क्लास आई विल डिस्कस प्रॉब्लम्स रिलेटेड टू दिस. इतना आप रिवाइज कर लेना. नेक्स्ट क्लास में इन सारी चीज़ों पे वी विल डू प्रॉब्लम्स. ओके ओके, थैंक यू.
Thank you, sir.
थैंक यू.